Okay. So we've started solving quadratic equations. How can you tell if an equation is quadratic? What's it got in it? A square, an x squared, okay? And we solved some pretty straightforward ones by taking the positive and negative square root. But there are more complicated quadratic equations, and I told you that there were a couple of different methods. One was by using factoring. So before we actually see how to solve them, I think it's important to review, although there have been factoring questions in your exercises all year long. So I'm assuming that you guys, and no one's ever asked about a factoring question. So I should be able to give you a factoring test right now. Okay? No, everybody looks calm when I said that, so I guess that's maybe a good thing. Either that or you hide your emotions well. Okay. What is factoring? When we factor something, what are we doing? It's kind of nice to know what you're doing, because we've been talking about this. We talked about it a lot last year. We're going to be talking about it a lot this year. Huh? Not common multiple. Yes, common factor. That's one way to factor. Yes, that's true. That's a method of factoring. Okay. But when we factor something, like if I asked you to factor 20, what am I asking you to do? What's that? Okay, yes. Yeah, break it up into numbers that multiply to get 20. So it could be 4 times 5, could be 10 times 2, could be 20 times 1, could be 2 times 2 times 5. Okay, you can have more than 2 factors, but normally it's 2 factors that when we break something up. So we're breaking something up so that when we multiply these 2 things together, we get the original expression. Okay? And remember, we talked about 4 types of factoring last year, so we'll talk about GCF first. So what we're doing with GCF factoring, like we're doing with all the other stuff, is we're taking this expression and we're breaking it up into 2 expressions that multiply to get this. Okay? Well, greatest common factor means I have to look at all the terms and pull out the greatest common factor, not just the numbers, but the variables as well. What is the maximum I can take out of these? 3. That's one of my factors. So now I have to figure out 3 times what gives me 3x minus 9. Well, just divide these by 3. So 3x divided 3 minus 9 divided 3. Right. So I've broken it up into 2 factors. The factor 3 times the factor x minus 3 will give me this. That's it. I've added a couple other examples, but we're not really going to see too much of this complicated stuff with GCF factoring. From this point on, you're going to see pretty easy GCF factoring, almost like this. Okay? But it doesn't hurt just to refresh our memory. What's the greatest common factor of these 3 terms? 2, x. Because I can take a 2 out of all of them, and I can take an x out of all of them. That's my first factor. My second factor is when I divide everything by the GCF I just found. So what do I get? 2yz.
4z. Subtract 4z.
Subtract 4z. Plus 1. Good. Because remember, 2x divided 2x is 1. They don't just cancel each other out to nothing. Here I've got some exponents involved.
What's the GCF of this one? 4
Maybe.
AB squared. I can take 4 out of all the numbers. The most number of A's I can take out is 1, and the most number of B's I can take out is 2. That's my first factor. My other factor is when I divide. So I get 4AB
Plus 3A
plus 3A
minus 2B.
plus 2B. Good. Okay. It's pretty straightforward. Remember, GCF factoring, you could have 2 terms, you could have 3 terms, you could have 4 terms, you could have 5, you could have as many as possible. For this next time, and I'm doing this in a slightly different order that I did last year, okay? There can only be 2 terms. They have to be separated by a minus sign, and the 2 terms have to be perfect squares, meaning you can find something times itself that gives you this, something times itself that gives you this. And this is what we call a difference of squares. Difference means subtraction, squares means 2 perfect squares. Do we remember how to do this one?
X plus 5.
So it's always going to break up into 2 factors, 2 binomials, always. And I heard somebody say x plus 5, x minus 5. So when we see a difference of squares, it'll always be 2 binomials times each other. It will always be plus minus the signs. And how do I find the first 2 terms? It's what times itself gives me x squared. How do I find the last 2 terms? It's what times itself gives me 25. This one's pretty straightforward. The difference of squares. As soon as you recognize it as 1, you don't even have to do any math yet, and you can set it up like that. What are the first terms?
4M.
4m,
11M.
11n. We're done. Okay. Now we get to certain types of trinomials. If we've got a trinomial that has an x squared, an x, and a number in it, we can always factor it to 2 binomials. Always. The first terms in each binomial will be x. So again, I'm there and I haven't even done any math yet. How do we find the numbers? Do you remember? Yes. They have to have a sum of the middle number, -7, and a product of the end number, +12. So what 2 numbers add to -7 but multiply to +12? Well, they both have to be negatives. They have to be. -4, -3. Yeah, whenever it looks like x squared minus then plus, the signs are always going to be minus minus. Just like if all the signs were plus, all the signs in the binomials would be plus. Yeah. I can go to there. my two numbers must add to positive 2, multiply to negative 15, which means one must be positive, one must be negative. Plus 5 minus 3. Correct. And this last one, well, we were doing examples like this in the last unit. Perfect square trinomials.
Plus 4 plus 4.
Plus 4 plus 4. And if they're identical, what's the easiest way to write them? X plus 4 in parentheses squared. And we did that when we were completing the square. Those three should be considered pretty straightforward. This last one takes some practice. But you guys did well with it last year. Okay? And it's another trinomial with an x squared and an x and a number, except this time there's a number in front of the x squared. We can't do the sum product rule here. So we have to do a slightly different method. First of all, it's going to do this. Two binomials again. Now remember, the reverse of factoring is multiplying. So if I were to find my answers here and multiply them, I'd get back up here. Well, these first two terms here must multiply to get 2x squared. What do these terms have to be? 2x and x. So I know that if I multiply this back through, it's going to work here. These two numbers must multiply to get the end in the original. And since everything's plus, that means both numbers have to be plus. So I'm just going to do this, plus 3 plus 1. I could have done plus 1 plus 3. Okay? But I don't know if this works yet. Remember how we check to see if it works. Multiply the outside, multiply the inside, add them together, see if you get this. So 2x times 1 is 2x, positive. 3 times x is 3x. Yep. We're done. If I got a completely different number when I tried this rainbow, then I switched the numbers. If I got the same number but a different sign, then I switched the signs. This next one, well, now I got a choice for the first two, because there's two things, two pairs that could multiply to get 4x squared. 2x squared times 2x squared, or 4x squared times, or sorry, 2x times 2x, and 4x times x. Do you remember what I said to try first? Try the ones that are closer to each other. So try the 2x and 2x first, because a lot of the time, that's going to be the one that works. Okay, so this works. The two numbers here, they must multiply to get -3, which means one is positive, one's negative. -3 plus 1. Let's rainbow it to see if we got the middle term if we multiply back through. 2x on the outside, minus 6x on the inside. Yes or no? Right. Got the right number, We got 4x, but we got negative 4x. So that means I gotta switch the signs. Exactly. And that's gonna be left. Because that'll give me minus 2x and positive 6x, which does combine to get 4x. Okay. Try the next two. Put quite a few examples of this one up because, again, this one you get good at when you practice it. If you just look at it once in a blue moon, it's hard to do. So before I do any math, I know it's going to be that. And actually, if I look at the signs, I know it's going to be that. So what fits?
5 plus 1.
2x plus 5, x plus 1? Yep. Because if you rainbow that, you get 2x, 5x, it's just 7x. I know one's going to be plus, one's going to be minus, and I know the last two numbers are going to be 1. Question is, does the plus go first and then the minus, or does the minus go first, then the plus? What do we get?
7B plus
7b plus 1, okay? 1b or b minus 1. That gives me minus 7b, positive b, which does in fact simplify to negative 6b. Oh, we're going to do that for the rest of these. Well, I think we can all agree that those are going to be the first two in each binomial. We need 3 and 1, and then plus and minus, but they got to fit in such a way so that when I do the outside, inside, I get plus 14x. Minus 1 plus 3 doesn't in fact work. And this last one, well, I know I've got 2n and n. Middle's negative, but the end is positive, so that tells me that both signs have to be negative. So it's either 11 and 1 or 1 and 11. 1 and 11 will get you the right answer if you multiply it back through. Okay? That's good. You guys are good at these ones. Okay.